Good morning, good afternoon, good evening. Again, I want to welcome you to this webinar series, which we're calling Geospatial Knowledge Sharing for Professionals. And we're focusing on standards and open models for geospatial solutions, and where we will have three webinar sessions. Today's session, we're focusing on Spatio Temporal Asset Catalog, or what is commonly referred to as STAC, and we will have a presentation by Michelle Roby, who is the developer advocate at Radiant Earth. My name is Charles Mwangi. I'm the Acting Director, Space Sector and Technology Development, and we're working collaboratively together between the Kenya Space Agency, Radiant Earth, Space, Dev Global, Spatial Collective on a project where we have been doing some activities related to drone mapping with the intention of developing some products that would enable us to generate label data that can be used for AI training, and that would form the basis of the conversation that we're going to have as we go along. But again, we want to hear more on the topic of the day, where we're looking at Spatial Temporal Asset Catalog. And we'll have a presentation by Michelle Roby, as I indicated earlier, who's a developer advocate at Radiant Earth. Without much further ado, I want to invite Michelle to introduce herself, as well as please go ahead with the presentation.
Thank you, Charles. Can you hear me okay?
Yes.
Great. So hello, everyone. When Charles introduced and said hello to everyone, I'm one of the people who is a good morning. You can kind of see the sun is starting to rise, but when I woke up, it was pitch black. So if you get bored, you can just kind of like watch the sun slowly get higher in the sky during my presentation. Okay, so I'm going to share my presentation and we'll just get this set up really quick. So hello, everyone. Thank you, Charles, for that introduction. I really liked hearing about a bit more about the Kenya Space Agency, and especially the aspect of the importance of education to the public. Charles introduced my role as developer advocate. A lot of people don't know what that is. I get that question all the time. And a big part of that role is education to the public. And so I'm advocating for developers, both internally on our team, and then also people who are using products that we create or that we help promote at Radiant. And so I'm really excited to be here today to help those who are learning about STAC and getting into the community a bit more, some of the basics that are out there. Before I jump into talking about STAC, I wanted to just give a brief overview of the organization that I'm a part of, called Radiant Earth. Our mission is to increase the shared understanding of our world by expanding access to geospatial earth science data. And how we do that is we act as an umbrella organization for important efforts that we see as valuable at the time. And so we are a place that many efforts can happen. So right now we have two main initiatives. The first is called Source Cooperative, and the second is the Geospatial, or the Cloud Native Geospatial Foundation, which is what's putting this event on today. So Source Cooperative is still in development. It's currently in beta. This is a quick screenshot of that homepage. It is basically the effort to share data easier over the web. So anyone, either organizations, so organizations like the Kenya Space Agency or NASA in the US, or anywhere from a small nonprofit to these large government organizations, and then including individuals as well. So you and I could share a data source here on Source. And the whole idea is to be able to share it easily over the web using the cloud, and then also be able to create URLs to share data easily. Like you can just send a URL to your friend saying, hey, here's my data set that I created, and here it is on source. So that's in development. You can go check that out, and we have links on our homepage to this site if you'd want to see that and learn a little bit more about that and explore new data sets. And then we have the Cloud Native Geospatial Foundation, which is the mission is to encourage adoption of highly efficient and accessible approaches to working with geospatial data over the internet. So that, and you can always read more about all of these initiatives online. Each of these have a website that's linked to from Radiant Earth. But this effort is where STAC falls into. So this cloud optimized geospatial formats guide is something that we just started hosting on the site. And if you're interested in learning a bit more about cloud native, if you've heard that term, but you don't really know what it means or how it relates to your work or how you can implement that in your work, this guide is a really great basic. It's kind of like the overall basic version of the presentation I'm going to give about STAC, but about all of the current cloud native formats that we see out there right now. And then we see, oh, I'm going to move this here. We see as important and up and coming. There's a lot of formats that might become outdated over time, and there's a lot of cloud native formats that might come up and that will come up in the coming years. And so we just want to educate the public about that. And so that's what this is. Oh, and then we have, I just remembered from seeing this message from Louisa, we do have a short poll that we can start, I think, let me see at this next slide. Yeah, we can do that now. So take a moment, and if you did the survey before the registration, you may have answered this question, but I wanted to do a quick check-in with the group that we have here today. Lots of people sign up for webinars and don't necessarily come, and some new people have joined since signing that poll out. So it's nice to see. The question is, what is your experience with STAC for those who are watching this recording later on? And so right now they're somewhat mirroring what we had, but slightly different from the original survey that we put out. The options range from never heard it before all the way up to being an expert in STAC. And right now, here, I'll just share it. Right now, it's looking like the majority of the people on this call have never heard of STAC before. Some people have used it or heard of it, but never used it. And then there's a few beginners, one intermediate and one advanced individual on the call. And so this is great because this is how I intended my presentation to be focused. Let's see. I'll leave it open for a second, but we're probably good to close it whenever, since we kind of have that general idea. And I already created my presentation, so. But yeah, so this is great. I created this presentation with the intention of wanting to educate people who have never heard of STAC before, and maybe those who have heard of STAC but haven't used it yet, to create a space for them to get new learning through this. So I wanted this to be as introductory as possible to this new group of people, both online on this webinar today, and then also those who are watching this recording later on, and hopefully using it as a resource. And so this slide deck, I'll share this out with all of you after the webinar. So no worries about writing down a link or anything. I have tons of links in here and graphics, but this will all be yours after the webinar. So just keep that in mind when you're watching and taking notes, and take that as an opportunity to maybe just enjoy and watch and be engaged, and know that you'll have access to all of this after. And I design it in that way so that not only today while you're watching this, but also in the future, you have something to go back to when you're wanting to, dive into different parts of STAC, which is the Spatio Temporal Asset Catalog. And I'll try to say that a few more times throughout it. There's, always so many acronyms in our world. And so sometimes people forget to spell them out, but yeah, STAC stands for Spatio Temporal Asset Catalog. And so when you are continuing on your journey with STAC, if you do, hoping you do, I want this slide deck and this video to be a resource for you to be able to continue to learn. I also at the end included a few links to tutorials and videos, and there's links throughout it linking to helpful documentation that you can use to continue your learning in the future. And there are tutorials focused on data providers, data users, and there's so many tools online. Sometimes it can be overwhelming how many tools are online. So that's why I wanted to create this and make it as curated as possible, and just help you all get an intro into STAC, Spatio Temporal Asset Catalog. And then I'll have a symbol throughout the presentation. So whenever this comes up, I'm going to take a moment to look at the chat, the questions chat, to see if there's any questions about that section that I just spoke about, to make sure that we're meeting those questions throughout the presentation, because there are, just like, it's both simple, STAC is both simple, but also can be a bit, can be a lot at the beginning. So I wanted to make sure that there's space for that we can make sure that everyone's up to date before we're entering into a new section of that. So please utilize that Q&A chat. And whenever, if there's any questions that I don't know today, we will be sure to get that question answered by someone that might know more about that specific topic within STAC. So feel free to put, whatever STAC related questions in there, and we'll be sure to answer them. I'll do this plug now and at the end, but whatever questions that I am not able to answer, we'll collect, and we actually have bi-weekly meetings for STAC. So the next one is actually this coming Monday, and I have this information at the end of the slide, but we will have people on that call that can answer that, whatever questions you have. And so that's like an encouragement to continue on with the community. But so, feel free to ask whatever questions you need in that chat. So this is kind of, this is the intro of why STAC got started. So on this slide, we have a bunch of different screenshots of different data portals from government organizations and private companies and all across the board. And STAC started back in 2019, about the idea of coming to as a geospatial data user, and there being so many portals out there from different organizations. And sometimes finding satellite data from a bunch of different portals can be really difficult, because you don't know where the data you're looking for, which portal it's going to be on, who's hosting that. If you are looking for a vast range of data, you don't necessarily know if you got all of the portals that are available. I know a lot of US government organizations have multiple portals for different organizations, for different agencies. And so this can be really overwhelming to a data user. And we want to make data sharing as easily as possible. So this is a quick screenshot of, if you're familiar with APIs, the application programming interface side of collection data access. Basically like the way that the data is accessed through the computer. So the APIs, so the way that you could queue data from these portals was all a little bit different in all of them. So for an example, if that doesn't make sense to you, something that was like a classic example for this is cloud coverage. And so one portal might have cloud coverage marked as cloud_coverage. And the range might be 0 to 100. While another organization might have cloud cover, so a slightly different name for that attribute, and their range being from 0 to 1. So each of these things had similar data, but the way that it was being described was slightly different on each site. So this also created the bottleneck of us as users having to get to know not only many portals and know how to get them, what it was like to get the data from them, but then also how each data portal varied, and how to access data differently from each one, which is a large burden on a data user and someone who's just trying to collect data for their geospatial project. And so then STAC was born, the Spatio Temporal Asset Catalog, which is the star of the show today. So, yeah. So what is STAC? What is a Spatio Temporal Asset Catalog? So basically, it's a metadata model. It's modeled off of JSON, which I'll talk about here in a bit, or GeoJSON. And it's a human readable, simple format to be able to describe a data set. And the idea behind it, as I was describing earlier, is for it to be a consistent language to describe geospatial catalogs, so that we don't have the problem like we saw here, where there's something that says min cloud cover and max cloud cover on one, but then just cloud cover on another, and having all different ways to try to explore and find that data. And so the idea is that it's, a simple way to describe all geospatial data. The big purpose of it is to improve search and discovery. And so, yeah, like I was describing earlier, and we'll get to see some good examples of what that looks like, of looking for data and finding the data that you're looking for in a more efficient way than having to go to many different portals to do so. And at its base, it's a very simple model, but then, so to be able to get metadata into a STAC catalog, the base requirements are pretty simple, which we'll look at all together, but then it's also extensible. So if you can meet the base requirements, but then there's lots of ways to add on additional information into your STAC catalog if you want to include that data. The more data you have included there, the easier it is for people who are looking for that specific data set to find it. So that's the idea behind STAC. A quick note of what STAC is not. It's not a complete replacement for other metadata standards. So if your government organization or your industry requires a certain type of metadata cataloging, the point of STAC is not to replace that, it's to enhance that. And so a lot of data is still cataloged in a different way, but then additionally with STAC. And so this is really great for search and discovery, as we were talking about earlier. And then it acts so it doesn't have to compete with other metadata standards, but just enhance and allow that data to be discovered more throughout the web and throughout the community. The other thing that STAC is not is a single source of truth. So like I mentioned earlier, there's going to be other sources that have information that is useful to it. And sometimes a STAC catalog might not have all the information you're looking for, but that doesn't mean that that doesn't exist somewhere else. And so ideally that data, a STAC catalog is fully filled out, but that's not our intention for that to be the one place where you get all of the information. And then another thing that it's not is STAC is not applicable to all kinds of data sets. So STAC, in its name, spatio-temporal, space, time. So that spatio-temporal asset catalogs can only catalog data that is for data that has a space component and a time component, which is geospatial data. And so there are different data sets that just doesn't apply to, that STAC, that can't be cataloged in STAC. And if it is being cataloged in STAC, it's not quite utilizing the total functions of a STAC catalog. So just something to note. There's also a little caveat that most spatio-temporal asset catalogs are for raster data, so imagery of sorts instead of vector data. But there are more ways that vector data is finding its way to fit into STAC. And so that's still in the process, but there are certain ways that vector data shouldn't be cataloged in a STAC, and there's certain ways that it could work. So that is a nuanced aspect of STAC that I'm still kind of trying to wrap my head around, but you can be safe with cataloging satellite data, and we'll talk mainly about that today. Okay, so the way I organized this, as I mentioned earlier, is I have a lot of links and basic explanations. And here on this slide, I have the STAC GitHub repositories. So if you're familiar with GitHub, it's a site where software is hosted basically, and it's the open source space for that. And so we'll go to a few GitHub pages today. We can actually just go to this one really quick right now, assuming you can still see my screen. If you can't, maybe one of the hosts can unmute and let me know. But
yes, we can see.
Okay, awesome. Thanks, Charles. So that's good because I'm wanting to share some links today. So this is GitHub, and this is an example of the STAC spec, so the base spatio-temporal asset catalog specification. And so we'll reference these a lot, but I just wanted to pull this up so you can get an idea of it if you aren't really familiar with GitHub. And so here I have these listed out and linked so that you can reference them later in the future. And we'll kind of go into each of them a little bit today. So the first that I just showed you is the STAC specification. So that's just the basic format of what goes into a STAC catalog, what pieces you need to build a proper STAC catalog to catalog data. Or if you're a user, what understanding what's in these pieces is also helpful. Then next repository is, or organization too, is the STAC extensions. And so I'll just show you these each quick. So the STAC extensions is when I mentioned earlier how STAC is simple. So the STAC spec has very specific things that you need to fill out to make a proper STAC catalog. But then if you want and you have more information that you're wanting to share, the STAC extensions is a place to do that. to expand onto information of the data. So I'll dive a bit more into this later. And then there's a separate GitHub repository for the STAC API, which I'll talk about each of these more later, but I just wanted to give you a quick overview. And this is for accessing the STAC data through an API. So I'll fill more in on that later. If that doesn't quite apply to you, that's fine. We don't dive too much into it, but I wanted to include all the basic resources here for you to look at later. And then the last one I have here is the STAC ecosystem. And this one is really great because it's where all of the tools, or many of the tools that have been built to be to work with STAC have been built. And so in this place, there are many tools. So here's a visual of that, of tools of like who would use a certain tool and which tools make sense for that. And this is going to be, if you continue to work with STAC, a place that you'll visit a lot. And so I just wanted to include those so you can click back to those later. You kind of understand the lay of the land that we're about to explore. And so we are going to start with discussing the basic STAC specification. I'm going to take a quick second to look at the chat, see if there's anything before I dive into that. Looks like some hellos here.
No questions yet.
Okay, great. Okay. Oh, that just jumped to my end. Sorry, one moment. Okay. So within STAC, there are a few components, and these are somewhat to organize the data better and also to clarify, just to keep things consistent. So within every STAC catalog, there's the catalog itself. Within it, you can have subcatalogs, which you can either label as catalog or collection, which I'll discuss more momentarily. So just a way to better organize the data, and then STAC items, and then the asset, which is the final downloadable file at the end. So STAC is based off GeoJSON. If you're not familiar with GeoJSON, it's a format for encoding a variety of geographic data structures. I remember from the survey that most of y'all are geospatial, work with geospatial data. So you're probably familiar with point data, line data, polygon, and then this is just the way to say data that has multiple points, multiple lines, and multiple polygons within a feature. And so this, so that is often for vector data. And then this last point, the geometric objects with additional properties are called feature objects. So within STAC, a lot of, actually all of the base items have the feature type, which we'll look at later. I don't want to say too much now, but I just wanted to include this basic intro to GeoJSON as a to expose of how STAC got started. So using this format that was already established long before STAC was a thing. And it's written, so it's human readable, but it's also computer readable, has the type of, so what's the data? So in this example, it's feature, the geometry of the data, if it's coordinates, so like a specific point in time or in space, and then the properties, so a description of that data. And so this existed before, and the creators of STAC felt like it was a good way to simply describe the data, but in a way that is familiar to people potentially, and that kind of already has a format established that works. So this is just GeoJSON, this is not STAC yet, but when we're looking at STAC, you're going to see a lot of really similar formats because many parts of STAC is just GeoJSON with additional fields. So this is an example of a GeoJSON file. We can see it on the screen. So it's a feature collection, and it's a polygon, and here are the coordinates for that. And we can see a preview of that on the map. And so this is really all that GeoJSON is. And it's very simple here, but it gives us actually a lot of information. If we look to the left this is all the information that we're gaining just from this simple few lines of writing. So that is the basis of what STAC is built upon. So looking at the STAC catalog, which is that highest level part of STAC, and also newcomers often come to me, and I even thought this when I first started too, is the acronym for STAC, if you've been wondering about this. So it's Spatio Temporal Asset Catalog. And that means that a STAC catalog is a Spatio Temporal Asset Catalog. And this is, I find that a little funny, but it's also slightly different. Like the Spatio Temporal Asset Catalog describing the whole system, whereas a STAC catalog is a specific part of it. And that might take some time. A lot of this might take some time to kind of get into and kind of resonate in your brain if you're not familiar with STAC, but I hope that you can continue to rewatch this video and go through these slides and the other resources, and it start to make sense. So if it feels a little overwhelming right now, that's normal. So I wanted to include a good amount of visuals in here. This is just an example of, so if this is a STAC catalog, what the file structure of a STAC catalog would look like. So there's always, so as I mentioned earlier, GeoJSON, the extension for that is .json. And so within each STAC catalog, there will be a catalog.json file. And that is, would be like the overall description of the STAC catalog. And then each catalog can look very different, but often it will make sense to organize the data into subgroups, like with thematically, or there's very flexible in that way, but I might have a data set that has it might have Sentinel-1, Sentinel-2, and Sentinel-3, and those would each be its own collection. And then I'd have data within that. And so that's the concept with, just to organize the data, and we'll dive more into that momentarily. But you also don't necessarily need to use collections. You could just have an item within your catalog there as well. And so this might make sense to you right now, it might not, but hopefully this graphic, the more you look at it in the future, it'll kind of make a bit more sense. Same goes for this one. This graphic is the explanation of the components that are necessary in a STAC catalog. So if I just pop back over to the GitHub page for STAC spec, there is the catalog specification, which is what we're looking at right now. And I also linked to the GitHub pages because that is where all of the documentation for STAC lives. And so when you're actually building one or when you're trying to read one, these sites are really helpful because you can go through and see, okay, like what was an item again, or what components are here. So within the catalog specification, there is information just talking about the catalogs, and then there's this table showing what is required to be in a STAC catalog. And so this table is just this graphic. This graphic is just a representation of that table. I believe that I have that table in this document as well. I'll come right back to this. I wanted to just show an example. So a STAC catalog, the components that are necessary within this, just as a baseline, are including the STAC version. So that is predetermined. Right now we're on 1.1 or 1.00. And so that would be included, and that's as a reference for someone who is viewing that data of when was this created, what components are necessary, very helpful for the user to understand that. The type, and so here it's inherently going to be catalog for the STAC catalog. So again, no real thinking that needs to be done on that. The ID for the catalog, that's going to be a unique identifier for the specific catalog that can be searched, and you can find it and usually describes the data in some way. And then can be a written description. So, or it needs to have a written description. This is a required field. So in this one, a simple catalog example. And then the links, there's no links in this example, but the links is what would describe, like, here's what's all in this catalog as like a general overview. So going back to this table, we just looked at this example that had the catalog, the type, which was set to catalog, the STAC version, which is the current version, STAC extensions, which I mentioned earlier, of how you can expand the data. That is just an optional field. It's not required, but if you have more information about your data that you want to share, you could do that in the STAC catalog. An ID to identify the catalog, a title, which is optional, but can be helpful if the ID is vague or you need some sort of clarification in there, a description, which I mentioned is just, like a short description of that data set, and then links, which are required to link out to the rest of the catalog. Because if it doesn't have links going to, here's where the data within this catalog is, it's would not be useful to a user. So I just wanted to go back to this graphic again, now that we've kind of looked through those a bit. I have a few of these graphics throughout this presentation, and everything that is in the dark blue, that is a required field, and everything in white is an optional field for that piece of STAC. And so we went through to have a STAC catalog, the ID, the type, which is always going to be catalog for a STAC catalog, the STAC version, which is just going to be the STAC version that you currently are working with, a description, and links are required. And then we talked about a title could be optional, and if you have more information, you can add STAC extensions. Okay, so that is the general overview of the STAC catalog, which is, just to look at this one more moment. And so we'll get to see a bit more of this later on, but that is just, this is the overhead description of the catalog. The next component is called the STAC collection. And a question I get often at the beginning of someone's STAC journey is, what's the difference between a STAC catalog and a STAC collection? Well, a STAC collection is a catalog but it just has more metadata. So I'm just going to jump to this really quick. This graphic is the example, similar to the one that I just showed you for STAC catalog, but for STAC collection. So here we just looked at the one that was the STAC catalog fields. So this in this gray box is everything that a STAC catalog requires, which was, we talked about the ID, the type, the STAC version, description, links, and then the optional title and extensions. So a STAC collection is all the information from a STAC catalog plus additional STAC collection fields. So for a STAC collection, you also are required to include a license, which is just, what type of licensing does that data have? And then the spatial extent of that data. Those are required, but then here in gray, we can see additional fields that a STAC collection could have. So the providers of the data, keywords that describe that subgrouping of the data, and then the assets that are included in that data. And we'll dive a bit more into STAC assets momentarily, but just so you know, those can be described in a STAC collection. And the other component that's not required, but it's strongly recommended if you're creating a subcatalog that is a collection, is a summary. So summarizing that data, it can be really helpful for a user. You're looking through the data. And I'm just realizing too, I'm describing this as if you're creating a STAC catalog. Many of you might not be creating STAC catalogs yourselves. Many of you might just be using STAC catalogs to do, to find the data that you want. But either way, having this understanding of how a STAC catalog is built can be very helpful for when you're doing your searching of data. So if you find a STAC catalog or a STAC catalog that has collections, you know that you can find licensing information about that data or the extent within that collection description. And hopefully you'll find a summary of the data as well. So I'm just going to go back a few slides back to what we had, this written description of the STAC collection. So as I mentioned, it's a catalog, but with additional metadata, which we just got to look at. STAC collections are used to group data with similar high-level data. So right here, I have a written description, and then the next slide, I have the visual of this. So in a scenario in which we had a catalog that had Sentinel-2 data and Landsat-8 data, each satellite could be its own collection. So then when you're searching within that collection, the lowest level data have similar attributes. So like the resolution, since Landsat 8 has 30-meter resolution and Sentinel-2 has 10-meter resolution, it'd be ideal for a user to be able to know within a collection that all of the base data have similar attributes. So this graphic is an example of the two components that we've discussed so far about STAC. So the STAC catalog would be all of the data within the dotted lines. And so that STAC catalog would contain all of this data. Whereas instead of just having it all in there and you have to search it all to find what you're looking for, we could have sub-catalogs, which are called collections, that have additional metadata that set them apart from the other collections. So we could have one collection that's the Landsat 8 or the sensor that's OLI. And that could be that one collection. Then we could have a separate collection that's the Cybers 4 AWFI, which is like another, equivalent to Sentinel-2 and Landsat 8. That data could be in its own collection. And then we'd have our Sentinel-2 collection with all the data for that project that was collected with Sentinel-2 data. And in this catalog, all of this data would be related in some way. In this example, it looks like maybe, they're all in the same geographic area. So if you're doing a project on Dubai and you want to have many different data sources, that could be the project. But then within it, it's like, okay, but then I have my Landsat 8 data, my Cybers 4, and then my Sentinel 2, and it's all separated out. So just a way to categorize the data and organize it. And then we just looked at this, remembering that the STAC collection is really just the description of a STAC catalog, but with additional metadata that's going to help distinguish that section of the data from other parts of that data. So as we saw before, this with the STAC catalog, this collection fields table is everything that is included for the STAC collection. And this becomes helpful if you're building a STAC catalog, or if you are, or a collection as well, or if you're just trying to understand, okay, like, what am I looking at here? What does this mean again? You can reference this table and understand what are the required bits, which in the graphic, everything required is in the dark blue, and then what parts are optional and what it is. So this is just a resource for later. And here is an example of a STAC collection. So as we saw in the STAC catalog, this description has the STAC version, the STAC type, but now this type is going to be collection instead of catalog. The license, which is a required field on the STAC collection, an ID, so that would be different from the catalog, that's unique to that collection, a description, and then the links will be linking out to what is inside of that collection. So the links for our Landsat 8 collection are going to be mostly different from those that are in the Sentinel 2 catalog, because it's linking to different data. And then it also will have an extent and the summaries explaining what's in there, what makes it different. So we've now looked at the top level STAC catalog, and then what is a STAC collection, so like a sub-catalog with additional information. Now we're going to dive into STAC items and STAC assets. So STAC items and assets are what live inside STAC catalogs and collections, and that asset lives inside of an item. So each item can be thought of, so it's a single scene or set of files for a specific location at a specific time. And each item must have one asset at least. And then the assets are the downloadable files that live inside of an item. So for example, we might have imagery of like a scene, and then with many bands. So, many satellite providers have imagery with, 8 to 12 bands. And each of those bands would be a different asset. So the red band would be its own asset. The blue band would be its own asset within an item of a scene. So we have a visual representation of that example here. The example we were just talking about earlier with STAC catalogs and the collections, we have the same example from earlier. So we have our Landsat 8 collection, Cybers 4, and then Sentinel 2. Then within the collection, we're going to look at this middle collection, and then there's many different items of data. So scenes throughout that project that are in that collection, so one of the data provider collections. Then from there, each item that's here, so each scene of data is going to have layers of data. So band 1, band 2, band 3. So yeah, the different color bands or within the spectrum. And each of those bands is an asset. And so these are the files that people are either downloading or working with within the browser or doing the actual analysis on. Those are the real files. Everything above is descriptions and groupings. Many people will download, like when I was in school, I would go and I would download a single item before STAC was a thing from Earth Explorer in the US and from the USGS, and I would download a scene, which now in STAC terms is an item. And then within that scene, I'd download all of the assets, so all of the bands, and then I'd often just use 3 or 4 of them to do my analysis. But I'd download the whole thing, and often, yeah, like I didn't have any grouping with that data with related pieces. And so STAC, we have that where we could say, okay, you can queue it where you're like, I only want the red band and the blue band and the green band from this specific scene from this grouping of data. And then I have a zoomed in version of that if from this image. So looking at the lower half of this graphic, looking at taking that item and looking just at the assets, which is, yeah, that broken up bands. I just have another visual here, since a lot of this is helpful to just kind of visualize and see many examples. So here we have the groupings, and then this is this kind of like based on what I've talked about might seem backwards, but sometimes we'll put additional catalogs inside their collections. So if you just had like additional ways that you wanted to be grouping your data, you might have a collection that has a catalog within it. But regardless, we have a larger grouping, then a subgrouping, and then within one of these tiles, so it looks like it's this one, each one of these is an item. And so we pull that tile out, and seeing all the bands in each of those is its own asset, which is the downloadable file that you would actually work with. So going back to the graphics that we've been looking at, and mentioning, we talked about GeoJSON fields earlier. A STAC item is these basic aspects of a GeoJSON plus some additional fields. And if you haven't already picked up on that yet, we've talked about that some STAC is built upon GeoJSON, and it's just taking a GeoJSON and adding extra fields that are now required to build a STAC, and then that being the new baseline. And so for a STAC item, we have the required GeoJSON fields of the identification, the type, the geometry, the bounding box, and the properties, which include many other parts, which we can look at a little bit. And then we add on the additional STAC item fields. Those are the things that make a GeoJSON go from GeoJSON to a STAC item, which is including that STAC version that we mentioned, links to both the things above it. So like, I'm a part of this catalog and I'm a part of this collection, and then links to the assets that it has as well. And then the optional thing to describe, yeah, the collection it's in, if it has a collection, and the extensions that it may be using. Putting this here just as another visual and as a reference for the future, whenever you see this table on the STAC spec page for an item, it is just describing the in-depth version of this graphic. And I included the links here. I'll click on this just to show you where it's located. So earlier we looked at the STAC spec. So the Spatio Temporal Asset Catalog specification. Within here, each of these sub-components has its own specification page where you can go and understand each better. And right now, oh, this is linked to the collection that should have been item. I'll fix that before I send it to y'all. So within the item spec, there is this table that we're looking at that describes those pieces that have to be in an item, and how they are, like what they are and how they're related, and just better descriptions throughout it, so that when you're looking at something, you kind of understand what that information is telling you. And then here is our example of a STAC item. So some of this is starting to get really repetitive, which is good. Shows you how parts of it are pretty simple, and there are repetitions within a STAC catalog sharing the same information throughout it. So we're always going to have that STAC version, the type. So once we get to an item, I think I briefly mentioned this earlier, but it may have not made sense in that context yet. The type for STAC items is always feature, because it's something that has more information than a point, line, or polygon, because it has multiple assets that have additional information. And so the type for those, so that's something that's consistent through all of these, is for the STAC collection, for STAC catalog and STAC item, the STAC version and STAC, or the type is always required, but it's kind of always clear what it's going to be, somewhat predetermined. And then your ID would be that specific item's identification. And then we'll also have a bounding box and geometry information, properties, and then what collection, if it's a part of a collection, what collection is it a part of? Links to other parts of the catalog, so you can navigate the catalog from each piece. And then, or you can get links to where you can get the downloads, which is the assets of what am I actually trying to download and how do I get to it, and where does it actually live. So that is an example of what a STAC item looks like. And all of these graphics are taken from one of the intro tutorials on the STAC site, and I link to that at the end of this. But if these are helpful to you, they'll both be in this presentation that I'm sending out, and also are on the STAC site tutorial section. As far as the object, or the asset object, that is, we're at the very end of the catalog. We're finally to the data that we want to download. And the only thing that's required from here is the link to the object itself. So it can be, like, where am I downloading this from? And then these other parts are optional if you want to include that. But most of the time, like, we're getting all of the information that we need about that from the higher up sections. And by the time we're to the asset, we know that's the data we want to download. And the most important thing is just getting the link to do so. Okay, so that was describing the components of the STAC specification. And now there's one add-on to the STAC. I've mentioned throughout this that there's ways to expand that STAC catalog, because we talked through, we saw a lot of the same thing. There's a few spots that we could enhance the information about the STAC catalog throughout it, but not too many. And so throughout it, we've seen a spot where, if you have STAC extensions, this is where you could put that information. Well, now the STAC extensions repository. So it's its own separate thing, and it's just basically ways to enhance the description of that data. So the best way to learn about extensions is just going to the GitHub for it. There's also a prettier version of the GitHub. This is just that same information, but displayed in a more visually like less distracting way without all of the GitHub stuff around it. And so we're not going to go through each of these today, but I just leave this as a resource for you. So there on this page, there's a list of all the active STAC extensions. And so a lot of them are already created. You are able to build your own and submit it to be included, but often you're probably at this point probably going to find the extension that you need if you're working just with basic geospatial data. There might be extensions. There are extensions to be built for more unique use cases in the future, but there are many that exist now that work with a lot of use cases. So yeah, depending on the data that you're working with, or if you find a data set that you're interested in that has an extension and you don't know what that means, you can go to this table and find it and understand it. So it has all of these with links to more information about that specific extension, along with its name that it's used throughout it. So we have one that I do have a slide on called the electro-optical, which is shortened to EO, which, not to be mistaken with Earth observation, but within the STAC extensions, it's electro-optical, or EO. And this extension is something that is used quite often because that's where the cloud cover or the spectral bands is included. And there's a lot of very common satellite information that's included in this one. But yeah, this table can be a resource you can look at later. And there's this column that I'll also just mention, its maturity level. So some of these are just WIP, work in process. So they're not fully released, or yeah, the version could be unreleased. And some of them are, they are released, but they're still in pilot, and you can read more about those maturity levels here. But it's kind of helpful if you look at them. The ones that are stable are the ones that you are likely being used a bit more than the other ones. So you can look through those and kind of have a better understanding of what are the common extensions that are being used. So going back to the slide deck, yeah, this is included for your exploration later. And as I mentioned, the electro-optical extension is a very common one. Within its page, there is, they each have their own page with information. And so if this is something you're using or wanting to understand more, you can go and explore this more. But here we have this item properties or asset fields. So there is the bands. So what bands are included in this, and I have an example of that on the next slide. We can also have the EO cloud cover, so then an estimate of the cloud cover of that scene, and then the snow cover, which can be the estimated snow or ice cover. And these are just very common attributes that data providers might want to include in their information about that data to help you as a user better understand what that scene looks like. So here is an example of the EO extension using the bands component. And so we have this information about, so this would be if someone was creating a STAC catalog, the data provider has all this information and they want to catalog this data. Or if you want to catalog data that's already out there, but it doesn't have a STAC catalog yet, and you want it to have a STAC catalog, you could do this as well. So all of this information is gathered. This is an example in Python. All of this data is gathered and put into this information. So we're looking here, the first band is the coastal band, the second band being the blue band, and talking about its description on the spectrum. The green, it has all this information. And then when building the STAC catalog, the EO bands extension was applied here and saying, for your information, here is what all of these bands and like what attributes they each have. And so this is actually from a tutorial on the STAC site that you can access as well later on. Okay, so that is the basic STAC specification. I'm not seeing any questions in the chat, so I'm going to continue on just to cover a few last things, and then we'll have a little bit of space for questions at the end. One thing I did want to clarify, everything we just described, that is a STAC catalog, that is a static STAC catalog. And then, as I mentioned earlier, there is something called the STAC API. So if people are wanting to search data on the web through APIs, that would be a dynamic STAC catalog. I'm not going to get too deep into the STAC API today, just since it's a lot of information at the beginning. But I did just want to include this distinction to explain the difference between a static STAC catalog, so kind of the one we've been looking through with all of the JSON. And there's still JSON in the STAC API, but just a little bit of that distinction. So a static STAC catalog is going to be the description we've been looking at with the catalog and the collections that has that hierarchical distinction. It could be on a server or on the cloud, or it could even just be on your personal computer. It makes this data searchable on the web. It makes it searchable when it's if you're looking on like a STAC database, and it's a lower barrier of entry to like build a static STAC catalog, and it's not going to change. It's reliable because there's no change moving parts within it. And yeah, as I mentioned, it's a single hierarchical organized catalog and a human readable. So you and I can look through, we just looked through a bunch of examples of components of a static STAC catalog. And that is related to the STAC spec repository. A dynamic catalog, so that's generated on the fly by a live server and is implemented in software as an HTTP-based API. And it's a bit more techie, but what's cool about it is that it can respond to search queries. And we'll look really briefly at that. And I have more resources on that if that's something you're interested in. But the cool thing with that is, yeah, we can search it. It's got a lot more searchability to it, which is really cool. And then there's also ways that can create kind of like different views of the data. Instead of just one, you decide that you wanted to have the data as like Landsat 8 and Sentinel-2 organization. You can actually create many different views of the data in a dynamic STAC catalog. That we'll look at really briefly here and after. And that all of the things that are related to dynamic STAC catalogs is through the STAC API spec. And so that is that third repository here. And I'm not going to really talk too much about this, but yeah, it's just because we're running out a little bit of time, but it's just a better way, another way for search and discovery of STAC. And so in here, I have some examples of tutorials of reading a STAC catalog that's static. So everything that we've kind of been going through, there's an example here, a tutorial using PyStack. So if you use Python, a lot of the resources around STAC are with Python. There's also other languages that have been written, or resources that have been written in other languages that are helpful, but a lot are around Python at this current moment. And so I've linked to an example catalog or example tutorial that lets you read a static stack catalog, and then one that uses PyStack client, so the API version of PyStack. And then this is how you would read a stack catalog that's dynamic through an API. So those are linked for you to look at later. And then the last section is just the ecosystem that I've now just briefly mentioned, where I'll just open this up quick. I linked to this earlier, but this is where all of the tools exist for STAC. And so on this next page, STAC Index is a resource that has tooling and catalogs that already exist. So up here we have existing catalogs that are for STAC. We have that you can look through if you're looking for a catalog and you want to know more. The one I mentioned earlier was how with dynamic catalogs, you can organize things in different ways. So this organization has organized the data. It's the same set of data, but in multiple different ways. So by date time, by instrument mode, by industry. So you can click through and kind of organize data in different ways, which is really helpful to a user. Then there's a tab for the STAC ecosystem. So there's a ton on here and it can be a bit overwhelming. And so these filters can be really helpful of, okay, I use Python and I'm trying to look at SAR data. And then that already narrows it down from like a huge list of tooling to 3 tools. So I encourage you to play around with this and see what tools are out there that already exist for your efforts that you're trying to do. And then there's a tab for Learn STAC that has tons of tutorials from online. The good thing about this is that there's lots of resources here that could address your niche need, but the downside of this is that there's no curation here. This is just everything. So if you're looking for a more curated list of data sets, that's when I recommend going to the STAC site. So on the STAC website, we have a tutorial section that has this many tutorials based on different languages. So Python, QGIS, R, command line interface, and some more specific tutorials too. But that's where you can kind of where we recommend you get started if you're new to STAC. And then this, I'm going to skip over this, but this is just some reasons of why so data providers, data users, and developers, why STAC is useful. And you can look at that at a later time if you're interested. But I just wanted to get to mentioning the recommended resources I brought up earlier. The best STAC specification, so that first one that we really focused on, there's a best practices page that is super useful for understanding the ins and outs of STAC. So this is really well maintained and has a lot of detail. So if you're looking for something specific, this is where you'd find it. Then we have the STAC site tutorial page, which I just showed you. And then there's just included one video. There's quite a few videos on STAC Online, but I particularly like this one because it's a no-code example of how a STAC catalog is built, which allows you to kind of understand what that looks like. Because with PyStack or any other resources that help you build STAC catalogs, a lot of that stuff's happening behind the scenes. And so it's really helpful because it kind of does it for you. But then also if you're a new learner, it's kind of keeps you in the dark of what's going on and what is all included in the STAC catalog. So I recommend that video as you're getting into STAC, just to, kind of understand like what these tools are doing behind the scenes. And then once you kind of understand that, then the tools become even more helpful because you know what they're doing, but you don't have to do the effort every single time. And just to finish it off, if you are looking through that STAC index that had, so those like lists of tools, and you click through and you realize that within the ecosystem, there's not a tool that you want, there's not a tutorial that you need for your whatever like language, programming language you work in, or spoken language that you work in, reach out to me. Part of my work with the STAC community is improving the education resources that are available to the community. And that looks like expanding the languages that we're teaching STAC in, and then also the spoken languages that we include STAC in. So we're in development with expanding our resources past English to meet a larger group of users. And with that, I'll just, I'll leave this QR code will take you to signing up for the Cloud Native Geospatial Foundation Slack organization. So that's just a simple way to keep communication with the organization. And then I mentioned this at the beginning, that we have STAC community meetups every other Monday at 11 a.m. Eastern Standard Time. And this link will allow you to join the Google group for that. That Google group is how we do all of our communications with emails. And then that's where you'd get the invite to join the meeting. And it's open to the public, and it's a great place to come if you're working on a STAC project or catalog and you're stuck. That's a great place to go to ask questions. It's also a great place to go to just get the stay up to date of what's happening and changing in the STAC community, and get to know the people who are involved with the effort. We hope to expand the number of meetings to accommodate for other time zones, but for the time being, right now it's at this time. So it's also a great time to come and say, hey, I'm here today, but I'd love a meeting at a different time, and see if we can accommodate for the other half of the globe in that way too. So, and that's all for today. I'll leave this up just in case people are using the QR code, but I wanted to, we actually are at time, but if there's any questions, and as I mentioned earlier, whatever questions you send, you can either send to me an email later, or leave them in the chat, and we can address those later on too if they don't get answered today. So thank you, everyone.
Maybe Michelle, there's one maybe that you can handle before we wrap up. There's a question by Ronald. It's on the chat. He's asking how the STAC information can be utilized, say, AI for agriculture mapping of different food. Then he also goes ahead and you mentioned Sentinel-1, 2, and 3. Also Landsat. Please elaborate on these data sets. I don't know what, maybe you, if you can respond to the first one. The second one is not very clear.
Yeah.
Yeah.
So to clarify on this, so STAC information, so you're asking it how it can be utilized for AI or aggregate mapping of different food crops, and some more of the like machine learning side of this. So STAC, so it doesn't like directly, you're not directly doing machine learning or AI with it, but it's a way to access that data and share out that data from those projects. So we have a lot of data that is machine learning. We actually used to be exclusively focused on machine learning data at Radiant Earth. And so that data, it would be a STAC catalog that had both the imagery and the labels for a project, and then people could take that and create models from that data. With the Kenya Space Agency, we have the same. We have a data set that has imagery and labels, and then people can take that, browse that STAC catalog, get the information they're looking for, and then apply that to their machine learning projects. So basically, STAC is just a way to help you access that data And then once you have that data, you can do that work with it. Daniel next week is doing a machine learning focused webinar. So I encourage you to go to that one and kind of learn how you can use data that you've found through STAC for those applications.
Thank you, Michelle, for that. Again, because of the time. Maybe I can request Luisa to maybe share a bit more on the upcoming slides, and then again, like Michelle indicated, if you have any questions that you would want to ask, feel free to reach out to her on her email. But I want to invite Luisa. You can introduce yourself and then go ahead and share what you should be expecting in the next 2 webinars that you're looking forward to in the coming.
Charles, could you put up that slide with the information for the webinars, please?
Yeah.
Hi, everyone. Louisa Diggs, and I'm the Director of Operations at Radiant. So many of you might have probably gotten emails from me. I've been helping behind the scenes to put these webinars together. And I hope that this webinar was very useful for you. Michelle, thank you so much. I found it very informative for myself from the comms perspective. So we do have 2 more webinars scheduled next Wednesday, October 18. We have the field boundary detection model webinar. And there you will learn how to integrate new data into an open model. So you don't have to start building your model from scratch. And we will use data from Moraga town in on the outskirts of Nairobi, which we recently collected with, if you look at this that slide with all those partners at the bottom, we collectively worked on collecting the data. And then we have November 1st, which will be the week after next week, the building footprint segmentation model. And there you will learn to adapt a baseline model developed by Dev Global, also using the same data from Moraga town. And then just be on the lookout for emails from me with instructions on how to join the next 2 webinars.
Thank you, Luisa. And again, we want to thank all of those who have joined us. Just quickly looking at the chat, see whether there is. So again, we'll share the slides Michelle was using, the notes that she was using for your reference. And again, also this recording will also be we'll post it on our YouTube channel, KSA YouTube channel, and we'll share that link on our social media. Again, we want to sincerely thank you for having created time to join us for this conversation, and we look forward to the next conversation that is happening on the 25th of October, where, again, like Luisa indicated, we'll be looking at how we'll do field boundary detection using AI models, using some of the data that we collected using drone for the Moranga region within Moranga. So again, thank you so much again, Michelle, for your time. Again, it was quite a lot of work and walking us through the different components, but I think it lays the foundation where we could potentially between ourselves, and again, also like you indicated in the beginning, that although not all of us will be involved in the cataloging of the information, it is important for us to understand how that information is organized, so that in terms of discovering that becomes much easier. Thank you so much for your time, and again, also Luisa and the rest of the team that has been working hard to make this webinar happen. We really appreciate your time and also for your wisdom, and again, more importantly, for the participants who are able to join us for this conversation. And next week, see you, and have a good morning, good afternoon, and good evening from whatever region you are at. Take care. Bye.